Meghna, and today we will be covering regular polygons. So I'm sure most of us know that polygons are plane figures with 3 or more straight sides. But today we will be covering all the elements of regular polygons. Regular polygons differ from normal polygons in that regular polygons have equal side lengths and equal angle measures. It's called an equilateral triangle. 4 is a square, 5 pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 12 dodecagon. Now 7 we don't really see that much because the angle measures are not a whole number or an integer, so we don't really see that much, but everything else we will be covering in depth. And feel free to pause the video and copy this down if you need to. So the first thing we will be covering are the number of diagonals. So what are diagonals? Diagonals are line segments of a polygon that connect non-consecutive vertices. So pretty much, if I were to draw a hexagon, we're going to pretend that looks regular because my artistic skills in drawing these shapes might not be accurate. If I were to label all these points A, B, C, D, E, and F, A to B, even though it's connecting 2 vertices, it is not a diagonal because they are consecutive. When I say non-consecutive segments, that means A through C, or A to E, or A to D, or B to F. Any of those are diagonals. But if it was B to C, C to D, D to E, those are not, because those are just the sides. So if we were to find the number of diagonals, we could just count them. So for a triangle, that would be 0. Square, we have 2. Hexagon, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure. But if I said that a regular polygon has 100 sides, how many diagonals does it have? You would probably be very confused and you'd probably not get the answer if you tried it this way. So there is a formula. And the formula is n times n minus 3 divided by 2. Where n is the number of side lengths, or the number of sides for the polygon, and this is how you would set it up. So if I said it was a decagon, you'd plug 10 in. So 10 times 10 minus 3 divided by 2 equals 10 times 7 divided by 2, and that's 35. So that gives you 35 diagonals for a decagon. So that pretty much covers diagonals. Now we're going to move on to angles of regular polygons. Again, I'm going to draw a hexagon. This line does not actually exist. I'm drawing it for a reference, so that way we know what each angle is called. So if the angle is inside the polygon, it's called an interior angle. And if the angle is outside the polygon and it forms a straight line with one of the side lengths, it's called an exterior angle. An important thing to note is that an interior angle plus an exterior angle is always equal to 180 degrees. Now we're going to look to find what each angle, interior angle measure is for a regular polygon, what each exterior angle measurement for a regular polygon is, the sum of the interior and the sum of the exterior angles. So to begin, how do you find the interior angle? The formula is very simple. It's 180 times n minus 2 divided by n, where n is the number of sides. Remember, this is only for regular polygons, because if it's irregular, this angle measurements can change. If you want to find the sum of the interior angles, you would do this formula, 180 times n minus 2 divided by n times n, the total number of angles, because this is each angle, this is the total number of angles, to find the total sum of all the angles. So you would cross out the n's, and you would be left with 180 times n minus 2. So far, so simple. Next, we have the sum of the exterior angles. To find the sum of the exterior angles, it's really easy. It's always going to be 360 degrees. Now you can probably easily guess what each interior which each exterior angle would be. There's two ways you can find this. You could do 180 minus the interior angle, because remember, they add to be 180, or you could do my favorite, which is 360 divided by n. And if you wanted to, you could work backwards. If I were to ask you to find the interior angle of a hexagon, you could find the exterior angle. So that would give us 60 degrees for the exterior. And then the interior would be 180 minus 60, so that gives you 120. That makes it a lot faster, but if you wanted to, you could just use the formula. So next, I'm going to do a chart. So this is a chart that would be really helpful if you copy down and try to memorize, because it makes doing math, especially competition math, that much quicker. If you can automatically know that the interior angle of a regular pentagon is 108, that makes your life a lot easier. That way you don't have to plug it into the formula. The formulas are also good to know in case you have a random number like a 100-sided figure or a 1,000-sided figure, but these are pretty much the basic ones that would be very useful to know. And my bad, I forgot 9, so I'm going to add that in. So if it's 3, it's called an equilateral triangle. Again, square. I've already covered this earlier, so I'm going to go through it really quickly. Pentagon, hexagon, octagon, nonagon, decagon, and decagon. Okay, so quickly, what you could do is pause this right now and try to fill as much of it as you can using the formulas that I just shared with you. But I'm going to go ahead and fill this out so that way you can just copy it and then have it to memorize. So that's it. If you take this chart, memorize it, it'll make math counts MAO very easy and helpful, especially in geometry related questions. or if it's just simply asking what is the interior angle of a pentagon, it makes it that much easier. So thank you for watching, and if you like this video, please give it a thumbs up and subscribe.